Hello, SENG 475 and ECE 596C students. I just want to take a few minutes to discuss the final exam in the course. And I thought I would do this by video because there's at least one student in the course who unfortunately, for very legitimate reasons, is away and won't be back until just before the final. So this is basically the only way I can communicate with that student about the final. And also it might benefit some other people if I can post this information early. So by doing a video like this allows me to do this. Anyway, so let's start out with the basics. This information that we're looking at now is actually on the course website, so you can download this document if you like. But anyway, I just want to add a bit of additional commentary to it. So first of all, the basics. The exam is on Wednesday, August 7th at 9 o'clock in the morning in ECS 124. Please double check this time. This is the time that I was told, but just in case I was told incorrectly, this is what I believe the exam to be in terms of the location and time. The exam for SENG 475 students and ECE 596C students is identical, so there's not any special exam for the graduate students versus the undergraduate students. Everyone writes the same exam and answers the same questions. The time for the exam is 3 hours. You may not necessarily need the full 3 hours. It's really hard to predict in a course like this exactly how much time will be required, but at least I suspect that you should be able to finish reasonably within 3 hours and possibly less time than that. The exam is a closed book exam. There is a crib sheet that's provided in the exam paper itself, and I've made a copy of a draft version of the crib sheet on the course webpage, so you can download it and take a look at it. It might give you some ideas of some types of questions that I could potentially ask, but please note that just because something appears on the formula sheet doesn't mean you'll need to use it. So you can't necessarily predict particular questions that are going to show up on the exam just on the basis of what formulas and tables are provided on the formula sheet. There's no calculators for the exam. The exam is comprehensive, so it covers all the course materials. And of course, this leads to the natural question, well, what did we actually cover in the course? Because we covered quite a lot of ground. So in this regard, there's videos of either all or most of the lectures for the course available through the course website. I say most here because I'm not sure if the last few lectures in the course, whether I'll have time to edit them and get them up online before the final exam, or at least within a reasonable length of time before the final exam. But at least I'll try my best, and at least the vast majority of lectures are already there because we don't have too many lectures left. There's also a list of the lecture slides that were covered during the lectures, and this is available also from the course website. And the list of lecture slides also has a link to the lecture videos, and there's a link for each time offset. So if you want to go to the particular video lecture, the part of the video lecture that was discussing a particular slide, you can just click on the time link that's provided next to the title of the slide in the list, and that will take you directly to the YouTube link at the time offset where that slide is discussed. So it makes it much more easy to kind of navigate and find material in the video lectures. So probably you want to make use of that when you're doing some studying and reviewing. So in terms of what types of questions I might ask on the final exam, I mean, obviously I can't tell you exactly what I'm asking. That would defeat the purpose of the exam, but I can try to give you some idea about the sorts of things that you're likely to see, the general types of questions that might be asked. I mean, ideally for a course like this, what I'd like to do, but I can't do, I just like to have everyone sit down in a lab with a software development environment in front of them and have them write code, basically give you some exercise to do and have you write code, test it, debug it, and submit it at the end of the lecture, maybe using Git. But I'm not going, at the end of the exam. But this is not practical to do because it would be impossible, for example, to invigilate the exam in such a way that you can make sure that no one's cheating, because I'd have to give you network access so that you can access references on the C++ standard library and so on. So it's just not feasible. So for this reason, the final exam is very, very different from the programming assignment parts of the course, like the parts B and part C from the programming assignments. Instead, what the kind of the best approximation I can make to the exam in terms of things that you've already seen would be the part A parts of the assignments that you've done. The part A part of the programming assignments wasn't really programming per se, but rather you're kind of answering concept-based questions, or maybe writing some small piece of code or something like that, but it's nothing like in the actual real programming exercises in the parts B and C. So this gives you some kind of guidance in terms of the types of questions that I might ask. I'm not saying that I'm only going to ask questions like the part A from the programming assignments, but it's probably a safe bet that some questions, at least, maybe not necessarily the majority, but at least some of them are going to be loosely based on questions that you've seen in the programming assignments. I mean, they're not, by loosely based, I don't mean they're kind of the same, but they're testing the same sort of concepts and maybe using a similar format of question. In terms of, so that gives you some idea about maybe some of the types of content I might be testing on. Essentially, I'm looking more for conceptual things because, as I mentioned a moment ago, like I can't really do the exam in the way I'd like, which is a practical one where you write code in front of a computer and you run it, test it and so on. So this forces me to go down the route of sort of doing things on a more conceptual level. So a lot of the questions are more kind of conceptual in nature, trying to understand, do you understand the basic concepts of the course and so on. So in terms of some of the types and formats of questions I might ask, as opposed to like the particular content they might be evaluating, there's a lot of possibilities that could arise. For example, I could ask you to analyze some code. I give you some code, like give you the source code for a program or a function or something, and ask you to explain what's the behavior of this program when it runs. Does it have undefined behavior? Is well-defined behavior? If it is well-defined, what does it do? Things like this. Or maybe just give you code for a single function, and I could ask you to explain what it does, or does it have problems with it? Are there errors in it or something like that? Another type of question I could ask is like a conceptual one. I could ask you to, give definitions of various different terms that are related to the course, explain certain concepts and so on. Like what are namespaces? What are the purpose that they serve in the language? Things like this, just as an example. I could ask you to write code, but I'm not going to ask you to write a lot of code. Like I can pretty much guarantee that anything that you're asked to write will be 20 lines of code or less. So it's not going to be anything like the programming assignments and nothing on that scale in terms of complexity, but basically just to understand or see whether you kind of basically recall something about the general syntax of the language and can recall something about what we've covered in the course. Anyway, so you don't have to worry about writing any great, huge pieces of code on the exam. That this would be very artificial, and I think it would be unfair because you don't even have a compiler that you can see whether your code compiles, and it's easy to make a mistake, leave out a semicolon or whatever, and then your code's wrong. Anyway, so for this reason, if you're asked to write any code, it will be relatively short. I could ask you to do some kind of numerical questions, like numerical computation type questions. So, like for example, in some of the part A parts of these programming assignments, you're asked to do things like like applying Amdahl's law to figure out which optimization was more profitable to do. You had some, I think, questions involving caches where you're asked to calculate number of cache misses or something like that. So there's some numerical type questions that I could ask you to do. Also, there were questions, for example, on computational complexity, like doing asymptotic analysis for time complexity, space complexity. Those sorts of things would also be kind of fair game. I guess they sort of fall into the category of numerical computation to a certain extent, maybe loosely speaking. I could ask like very short answer questions, like 1 or 2 words, kind of like fill in the blank kind of questions. I could have short answers, maybe on the order of 1 or 2 sentences, or I could have like a short essay question, like write a paragraph or 2 to explain some concept or something like that. So there's quite a variety of types of questions and formats that I might use. But again, in terms of the content, probably the best initial guide that I would say is to use the part A parts of the programming assignments as your initial point of departure for studying, and make sure you at least understand all of those concepts really well, like truly understand them, not that you just kind of memorize the solution from the solution set, because it's unlikely I'm going to ask exactly the same question. I want to know whether you truly understand. In terms of what you need to remember about, for example, the C++ standard library, because there's a lot of different functions and types and things from the standard library that you used in the programming assignments, and also may have used even in some of the part A parts of the programming assignments. I don't expect you to be memorizing large parts of the C++ standard library. I don't really see any point in that, but I would hope that you remember kind of the basic things, like you would know about std vector and maybe std string, and like some of the very basic kind of functions like sort, but don't be wasting a lot of time trying to memorize things from the standard library. The exam is not in any way, shape, or form intended to be a kind of a memorization exercise in memorizing stuff in libraries. And I don't think that studying in this way is going to benefit you in any way at all. But just make sure you know the basic stuff, and the very basic things, like if you've done the programming assignments, there would be not any way that you wouldn't know them. Like, I don't think you could get through this course and not know what std vector is, or get through this course and not know what std string is, just as some examples. And then in terms of how I would advise you to prepare for the final exam, because this is often a question students will quite reasonably ask, if I was a student, what would I do to prepare for the exam? So the first thing that I would recommend is go back and look at especially look at all of the part A parts of the program assignments. Look at the solutions that you wrote, compare them to the solutions in the solution sets, make sure that your answers actually are correct, and make sure that they're written up kind of in a equally good way as the way it's written in the solution set. Because sometimes students, I've noticed on final exams, they write things up in a way that I don't really understand. I don't know what the student is saying. And although on the assignments in the course, the TA probably tends to give you the benefit of the doubt. Like, if they're not really sure that you know what you're talking about, they might still give you full marks or most of the marks. But on the exam, the onus is on you to demonstrate that you know what's going on. So if you write things in a way that's not clear, where I'm not sure what you're saying, the assumption will be that you don't know what you're talking about, and you'll lose marks. So you might want to look at the way that some of the solutions are written up. Just if you feel that the way you wrote things up was maybe not the best way or not the clearest way, it'd probably be very worthwhile to look at how some of the solutions are written up, so that you get a better idea about what might be a good way, like a better way to write things up perhaps than what you've done, if you feel that the way you've done things might not be that clear. So again, like basically go through, review all the assignment solutions, especially for the part A parts, and make sure that the content that's covered by them you know well, and you could do questions of those sorts of types relatively easily. Yeah, I guess I mentioned, make sure that you look at the solution sets just to make sure that your answers actually were correct, and the TA just wasn't being very lenient in giving you marks for things that weren't actually fully correct. And also make sure that your write-up was kind of clear. I would also go through and maybe review the lecture slides for the parts of the course that are problematic for you. And this will be a very individual thing. Different students find different parts of the course material to be kind of difficult or more tricky. So for whatever areas that you yourself personally deem to be sort of more tricky parts of the course, probably it would be a good idea to go back and review the lecture slides for that particular content. And also keep in mind that the video lectures are also available to you, and they're all like indexed, so that you can easily go to the content for a particular slide by clicking on the link for that slide from the list, the online list of the video lectures in the course and the slides that were covered. Also, in addition to looking at the lecture slides, you may also want to view the part of the video, like the lectures that correspond to those slides, if you're trying to review that content. So that's kind of the last bullet that's mentioned here. Again, don't forget that those video lectures are there. I put a tremendous effort into making them available to you. And one of the main reasons I made them available, it was not so that you didn't have to attend the lectures, as I pointed out at the beginning of the course, but really it was mainly intended for review now. So like when you're preparing for the final, of course, a lot of stuff that I said closer to the beginning of the term, there's no way you'll remember everything I said, right? It's just impossible. But now if you need to review some of that content, it's there. You can go back and you can literally hear like every word that I said and all the content that was covered. Anyway, so please make use of those lecture videos. Hopefully they will help you a lot with the final exam. And I think that's basically all I have to say about the final exam for now. I'll probably spend a little bit of time in one of the remaining lectures to open up the floor to any questions that you might have based on what I've said here. But at least that's all I have to say at this point in time. So good luck with your studying.